on today's episode of Python Papi, we're back inside our smart contracts project. Let's have a look at what we're going to be going over today. Now, we're still doing a Web3Py favorites module, but today we're going to be deploying our contract. We're not going to be doing any light reading, so we're just going to dive right over here. This may be a little bit longer of a video because we have a lot to go over. So let's dive right in. So first and foremost, you can see we have our Anvil terminal up and running. Now remember, we have to have Anvil up and running before we do anything because this is the blockchain we're going to be deploying our contract to and making sure our transactions go through. So and then let's go down here. You can see we have our available accounts. So you can see how this first account here ended in 2266 is what we're going to use for our address. You can see my address equals 2266 for the last 4 digits. And then for this private key that's commented out, we're going to use the FF80. Let's move down and see. We can see that here. You can see our first set of private keys is going to be the FF80. So this is where we got our private keys from. Now it's commented out because I was attempting to do something. So we don't need it anymore. We already set it. We already used it in our code. So it doesn't matter if it's commented out or not because it no longer needs to be hard coded. So let's move on from that. So again, we opened up our second terminal. And you can see here we ran into an error. So the first time I ran it, this is just for an example. I actually ran everything through. And you can see it went all the way through to the building transactions. Let me move down so I can show you what it looks like here. Also, you can note that I comment out the breakpoint because I don't want to have a breakpoint. I wanted just to compile all the way through, but everything else should run the way it was. We're going to print out our favorites contracts, which contains our bytecode information. You can see the bytecode information here. You see the bytecode information, and we printed out the ABI information. Let me see if I can find the ABI. You can see the ABI here. So all of that went through, but then we run into an error. And you can see here after we start building the transaction, it wants us to enter a password. So you can see here we built our transaction. Everything is built and ready to be deployed. So let's move down some. But when we get to this section here, when we have to enter our password, it crashed because that all ties into our private key and our decrypted key. So I purposely put in the wrong password to see what would happen. And you can see here the contract didn't get deployed. So you can see here, and if you actually read over some of the error information, it'll give us hints as to why it crashed. You can see private key equals decrypt key. Then you can see key equals count.crypt. Decrypt, encrypted account password. You see password bytes, and then you see password. So you can see it starts repeating the word password over and over and over. Then you can see here MAC mismatch. So you can see here that our password is a mismatch and it didn't go through. So that's why it failed. So and then on the third attempt, I actually put the correct password in, and you can see everything deployed and went all the way through. So you can see here we can have the built-in the transaction. We have password. I put the correct password in. That gave us access to our decrypted key, which is our private key. That's decrypted because we encrypted it over here. Encrypt key file. We didn't get there yet, so you don't know what that's about. I'll hold off on explaining that to you until we get there. So you can see that and tell us to let us sign our contract. You can see here we have the signed transaction, raw transaction. We have our hex bytes. Let's move down. Then you can see here we have our RSV. Here's the R. Here's the S. And here's the V. I explained that to you yesterday. I'm not going to go over to that into detail. If you want to know what that's about, you can go watch our previous video. Then we have our transaction hash. Like I showed you before, this is our transaction hash is B, and this is the rest of the address. And then we have our statement telling us that the contract was completely deployed and transacted correctly. You can see here, done. Contract deployed to this address here. Now, not only do we have this information here when the contract got deployed successfully, we can go over to our terminal here, and we can see that everything was receipted, and we can actually have access to that receipt of that information. I actually did it a few times before I did it because again, I want to show you what it looks like from different variations. So the first time I did it, you can see today's date, Saturday 16th of August 2025. This is the timestamp from the first time I did it. This is the second time I did it, and this is the third time I did it here, the one I'm actually walking you through now. So this is our third block, Saturday the 16th August 2025, 14/28/13. I'm not sure what time zone that is, but yeah, and you can see this is our transaction receipt, and that ties back into over here where I showed you where we got that information from. Our So you can see this, so I copy and paste it from original from when I ran it back in June. So you can see Wednesday, the 4th of June, 2025. This is the timestamp. So you can see that the information is lining up and everything was done correctly. It's the same exact information. So yeah, everything is running correctly and everything is deployed correctly. Like I said, we have a receipt of it, not only in our terminal where we deploy the contract, but we have a receipt of it inside of the Anvil terminal. So let's just know this is the transaction that happened. This is the contract that was created, this address here. This is the gas that was used. This is the block number that it's on. This is the block hash, and this is the block time. Let me actually show you something else also. It should be a here. Let me see here. So you can see this contract deployed to OX9 and then in A6E0. We can go here and we can see here A6E0. So this is the contract that created. So letting us know that this is the contract that was created, or this is where the contract was sent to the A6E80. And this is in our Anvil terminal. So that's part of our Anvil receipt, letting us know where that contract was actually deployed to. So you can see that here is the same exact here in our deployed contract. See, contract deployed to A6E0. So yeah, that's basically how we did that. And again, I did set the password, and that's why it allows us to go through. I set that here in our encrypted key file. Again, we didn't get there yet. I'm sure we didn't get to that point yet, so I'm not going to go over to that yet because I don't want to confuse you. So yeah, we put our private key in this encrypted file and we encrypted it so no one can have access to it, and we no longer have to hard code it. That's why you can see it's commented out inside of our contract, and everything was still able to go through. It's because we no longer have to hard code it. We actually hard coded it, we removed it. We actually put it in our encrypted key file, encrypted it, and then we set a password for it. So we no longer can deploy contracts without that password, because the password decrypts our private key. Our private key signs our contract, and our contract gets deployed. So yeah, when we get there, you'll understand exactly what I'm saying and why that's important. So yeah, basically everything is working the way it should. Like I said, I went back and fixed everything back to its original form. And as you can see, our contracts are deployed. And initially, I wanted to run this for you live, but of course, trying to do all this compiling while running the video was a major headache, and there was a lot of holdups, and it was taking way too long. So yeah, I just decided to pre-compile and then show you what it looks like afterwards. So yeah, like I said, pretty interesting stuff. Let me make this a little bit bigger so I can. Pretty interesting stuff. If you want to go back and watch this video again, just to see exactly what's going on, you can. This is our contract here. Everything was deployed. We deployed to our Anvil terminal. Here's the receipt of that deployment and that transaction. All of the timestamps, the contract created, the gas used, the block is on, the block hash, and the time it was created. So yeah, here's the version of it where we put in the wrong password. Like I said, we set our password already. So once the password is set for this address, that's it. And the address that we used, I showed you already, was the one we got from the Anvil, the mock. So once the password and the private key is set for this address is locked, we no longer have to hard code it. So we set the password, and we were able to comment out the private key. And as you can see, everything's still deployed, but without putting in that proper password. It doesn't matter if you have the information set up correctly or not. Without that password, the contract isn't going to deploy. So you can see here we got our error. And on this attempt here, you can see I put in the proper password, and we have our transaction. So that's basically everything so far, and you were able to see. Well, you weren't able to see it live, but it's as live as it can get for now. Basically, our contract is coming along quite nice, so we're going to keep moving forward. So yeah, tomorrow we're going to be starting a new module and going over some information. I can't wait till we get this encrypted key file so you can see exactly how we put everything together, how we encrypted those keys, and how we encrypted the private key, and then how we decrypted it using the password. All that stuff is pretty interesting also, so stay tuned for that. But of course, I will keep you posted every step of the way. But for now, it's the Python Papi. You guys stay Gucci.